Welcome back to Code and Current Studio. We are adding to the Arduino vehicle cooling and auto AC system project. In stage 3, we're adding automatic cooling logic to simulate how a real vehicle responds to cabin temperature changes. This includes activating the blower motor, controlling the AC compressor, and adjusting the coolant cutoff valve using a servo motor. Let's dive into the components, circuit, and code. We are reusing the stage 1 and stage 2 components, the Arduino board, temperature sensors, potentiometer, breadboard, and LCD screens. We will be adding a few new components: the blower motor, the vibration motor to represent the AC compressor, and the servo motor. The cabin temperature sensor connects to analog pin A2, and the desired temperature potentiometer connects to analog pin A1. The blower motor is controlled via PWM on pin 3 and uses a transistor-based circuit for safe switching. Similarly, the AC compressor circuit is triggered through digital pin 4 and uses a transistor for control. The coolant cutoff valve is a servo motor connected to PWM capable pin 5, allowing a precise positioning based on temperature logic. The LCD displays the coolant temperature, the actual cabin temperature, and the desired cabin temperature setting. All right, let's take a look at the code. The code reads both cabin temperature and the desired temperature setting, calculates the difference, and adjusts the blower motor speed, coolant cutoff valve position, and the AC compressor signal accordingly. If cooling is needed or the desired temperature is less than the cabin temperature, the AC compressor signal is activated and the coolant cutoff actuator closes the cutoff valve, blocking coolant flow to the heater core. If heating is needed, for example, the desired temperature is greater than the cabin temperature, the AC compressor signal is de-energized, and the coolant cutoff valve opens, allowing hot coolant to flow into the heater core. The blower motor speed is scaled proportionately to the temperature difference. The greater the gap between the actual cabin temperature and the desired setting, the faster the blower rotates. Both the blower motor and the AC compressor circuits use transistors for safely switching higher current loads. The coolant cutoff actuator is connected to a PWM-capable pin on the Arduino, allowing precise control of the valve position. The LCD screens update only when temperature readings change, reducing flickering and improving readability. All right, let's start our simulation here. We can go through the new components. So we still have our coolant temperature displayed, still have our cabin temperature and the desired temperature. This vibration motor represents the AC compressor. This is the coolant cutoff servo. And here's our blower motor. We can see running currently at 2600 RPM. Let's see what happens when we go cooler. Let's go a lot cooler. So the desired is 61 degrees. So this cuts off hot coolant to the heater core. We can see our compressor is on, and now our blower motor is spinning at 10,000 RPMs. So let's get a little closer to that 77 degrees. So we can see that our blower motor is spinning at 2600 RPMs. All right, so let's go hot. So when we go hot, we should see our cutoff valve open, allowing hot coolant to the heater core, and the compressor should shut off. so our blower motor would be running at 7,000 RPMs. Try adjusting the potentiometer to simulate different desired temperatures. Watch how the blower motor and compressor respond. Share your ideas in the comments. If you're following along, consider picking up an Arduino starter kit. It includes all the components we've used so far and more to expand your learning. Check the video description for links to recommended kits and components. That's it for stage 3. You've now added automated cooling logic to your climate control system, including dynamic control of your blower motor, AC compressor, and coolant cutoff valve. This stage brings your HVAC simulation closer to real-world vehicle behavior by responding intelligently to cabin temperature changes. In stage 4, we'll expand the system further by visualizing fan speed and vent mode on a dedicated LCD screen. We'll also automate airflow direction using 2 actuators, a blend door actuator to mix the hot and cold air, and a vent control actuator to direct airflow to dash, bi-level, or floor vents. Keep building and don't forget to like, comment, and subscribe for more Arduino tutorials and project walkthroughs.